The offshore platform was not destroyed by an explosion. It began with a small fatigue crack near a weld. On March 27, 1980, the semi-submersible platform Alexander L. Kielland was operating in Norway's Ekofisk field in the North Sea. At the time, it was being used primarily as an accommodation platform for workers. From the nearby Edda installation, there were 212 people aboard. The weather was rough, with strong winds and heavy seas, repeatedly loading the structure. At around 630 p.m., workers felt a sharp crack and severe vibration. The platform suddenly began to list. Investigators later traced the structural failure to a tubular member, known as brace D6. A small support for a hydrophone had been welded into this brace. Around that welded connection were manufacturing defects and severe stress concentrations. Every North Sea wave flexed the structure. With every loading cycle, a microscopic fatigue crack slowly grew. Eventually, the crack propagated around the brace. On the evening of the disaster, D6 finally fractured, but the failure did not stop there. The loads previously carried by D6 were transferred to the remaining braces. Connecting the same buoyancy column, those members became overloaded and failed in rapid succession. One of the platform's 5 supporting columns effectively separated from the main structure. With a major section of buoyancy gone, the platform suddenly listed approximately 30 degrees. For a short time, one remaining anchor cable helped prevent a complete capsize. About 20 minutes later, that cable also failed. Alexander L. Kielland overturned. Lifeboats and life rafts were difficult to launch from the heavily tilted structure and rough sea. Of the 212 people aboard, 123 were killed. Only 89 survived. The investigation ultimately found that the disaster began, not with the failure of the entire platform, but with fatigue cracking around a relatively small welded attachment. The accident became a landmark case in offshore structural safety. Welding quality, fatigue design, structural redundancy, and emergency evacuation. A massive structure did not need a massive crack to fail. It only needed a small crack that was allowed to keep growing.